Hello. In this video we're going to talk about electronegativity and the polarity of bonds. Electronegativity is the ability of an atom to attract bonded electrons or shared electrons. And so let's look at this version of the periodic table that lists some electronegativities of some atoms. And you'll notice that fluorine has the highest electronegativity. It's got an electronegativity of 4.0. And the other atoms have been assigned an electronegativity relative to fluorine. So fluorine has the highest, greatest ability to attract electrons that is sharing with another atom. And so if we look at that period going across from lithium to fluorine, we can see that as we go across the periodic table from left to right, the electronegativity increases. Lithium's got a electronegativity of 1.0, whereas fluorine has electronegativity of 4.0. And this makes sense if you remember that nonmetals are to the right on the periodic table. They want to, in fact, gain electrons. They very much like electrons, whereas metals want to lose electrons when they form ions. And so that makes sense that as we go across the periodic table from left to right, electronegativity increases. And if you look within, just say the halogens, and it's true for most of the groups or families on the periodic table, as you go up the periodic table, electronegativity increases. And so as you go from something like francium with a 0.7 over to fluorine, the electronegativity increases because you're going from left to right, you're going from top to bottom. There are a few exceptions within the transition metals as we look from top to bottom, but as a general trend, that is correct. And so electronegativity gives us a way of measuring how well an electron pair is shared by the atoms that are bonded to it. And so the two extremes would be a pure covalent bond, where the electrons in a bond are evenly shared. The other extreme would be an ionic bond, where it's held together by opposite charges attracting one another. This electrostatic interaction. And in between, we'll have a polar covalent bond, where the electrons are unevenly shared. And so from a symbolic standpoint, in an ionic bond, where say we've got some sort of metal M and some sort of nonmetal X, these are complete charges. There's a plus charge and negative charge. We have pure ions. Whereas a pure covalent bond there would be a perfectly even sharing of this. The best example of this would be something like fluorine to fluorine. They both have electronegativities of 4.0, so there's a very equal sharing. Whereas in an ionic bond, say something like sodium fluoride, where sodium has an electronegativity of 0.9 and fluorine is 4.0, that difference in electronegativity is 3.1. That delta, that triangle, is a capital Greek D, and it means difference. And so that's a very large difference when it comes to electronegativity. In a polar covalent bond, something like, let's say, carbon bonded to nitrogen, where nitrogen has electronegativity of 3.0 and carbon 2.5, that difference in electronegativity is equal to 0.5. And so there's an uneven sharing of electrons. And so if we were to look at this molecule, this nitrogen has an uneven tug on those electrons. That electron density is going to be greater toward the nitrogen, if you want to think about it that way. And so this nitrogen, relative to the carbon, is going to have a partial negative charge. This is a lowercase Greek delta, this little tadpole looking thing, and that means partial. And so we're looking at, they're not discrete unit charges as we have in an ionic compound, but they're partial charges, an uneven sharing of electrons. So numerically, how do we differentiate this? In an ionic bond, the difference in electronegativity is greater than or equal to 2. In a pure covalent bond, this difference of electronegativity is going to be less than (0.5). And so for a polar covalent bond, this difference in electronegativity is going to be greater than or equal to 0.5 or less than 2.0. And so that's a quantitative way of talking about the polarity of a bond. When we start talking about polarity of molecules a little bit later in this semester, like the next chapter, whether a bond is polar or not will be an important concept to understand, but it'll be, when we talk about the polarity of a molecule, you have to look at the overall shape of the molecule and how the bonds are arranged around it. And so we'll talk about that in a good bit of detail then. And so this is sort of an introduction to electronegativity and whether bonds are polar or nonpolar or somewhere in between. Thanks for listening.